All right, so now let's actually apply this to see which ones are these. It says identify the postulat or theorem that proves the triangle's congruent. Now I'm going to mark this. This one says it's 150 degrees, and I know these two smaller angles are both 15 degrees. Notice if I mark one of the angles, I have triangles, I have angle, side, angle. So those two triangles are congruent by angle, side, angle, congruence. Now, let's look at the next one. They tell me I have two right angles there. Oh look, two right angles. If I don't have another pair of angles, I can't use angle, angle, side or sine, angle, side, but I can use the fact that those are two right triangles, and I have a hypotenuse and I have a leg for each one. So that's the hypotenuse leg congruence. Now on the next one it looks kind of funny because the congruent angles are marked down below. Well, they also can be marked above because of vertical angles. And then when you do that, if I mark one of the triangles like we've been doing, we get sine, angle, side. So it's sine, angle, side congruence. Now, let's look at the next one. It says determine if you can use the hypotenuse leg congruence theorem to prove the triangle's congruent. If not, tell what else you would need to know. All right, in order to do this, we have to have two right triangles. We have to have congruent hypotenuse or hypotenuses and two legs. Well, obviously we have the right triangles. So right triangles, check. Because if one's a right angle here and they're a linear pair, the other one has to be a right angle. I can tell that the hypotenuses, which are opposite the right angle, I have those. I need a pair of congruent legs. Well, the cool thing is the reflexive property works. So that does work. So yes, HL congruence works. Because I have the right triangles, I have congruent hypotenuses, and I can find a pair of congruent legs, because those would be the shared side. But let's look at the next one. It doesn't work that way. Yes, I have right triangles, here and here, and I have congruent legs, but what's missing? Exactly, I don't know anything about the hypotenuses, so I don't know if they're congruent or not. Hopefully they would be, but you know, I don't know this leg, so I can't use the Pythagorean theorem either. So one would need congruent hypotenuses in order to show the triangles congruent. All right, now look at this one. Looks real familiar. So we're going to do about half of these. Now this will show up on your test. Again, we'll have more space, and they'll also probably be given information that you need. But we need to make sure that we can use all the different ones, and sometimes you can use more than one with these, which I really like because it gives us little options. So we have to decide if we can use any of these, and we have to write their congruency. No, actually, let's see, do we do that? Yep, and we have to write the congruency statement if they are. If not, we write not possible. All right, for the very first one here, notice I have pair of congruent sides. I have the corresponding sides because the reflexive property are congruent, and so I have a side, angle, side. So that's going to be the SAS congruence. The triangles, I'm going to write down below, are triangle BAD is congruent to triangle BCD. Now I look at the next one. Again, oh look, I have a side, not enough info. Not possible. I need a third piece of information. I don't have that third piece of information. Now, number 3, you should remember here on this one, I get a side, angle. Oops, we don't have an SSA. It doesn't work. So I turn around and say not possible. The reason why is the angle needs to be between the two sides. It needs to be included, and it's not. Now, looking at this next one, on number 4, I'm looking at these triangles, and I notice I have a pair of vertical angles. Now when I do that, look at this. I have a side, I have an angle, I have an angle. Isn't that angle, angle, side? So by angle, angle, side congruence, these two triangles do work. So I'd go triangle WXY is congruent to triangle AZY. Now that's angle, angle, side congruence. Now on this one I do believe that's supposed to be an S, so if you want to add that in, I'm looking at this again going, okay, how do I do this? I have angles marked between these two sets of triangles, but remember they share a common side. So I have angle, side, angle. So the two triangles would be triangle TSV is congruent to triangle. If I go TSV, I'm going to start here and go VUT. And that's by using angle, I'm trying to find room, we'll put it up above, angle, side, angle, congruence. Alright, how about 6? Well, once again, I love this. Our vertical angles help us out. And that gives us angle, angle, side. Or if you said side, angle, angle, that means the same thing. So just go ahead and use that one. So with this one, I have angle, angle, side, congruence. My triangles are triangle BEC is congruent to triangle DFC. Are you guys starting to see the routines and why I mark at least one triangle in order to prove these correctly? Now, one thing I always double check is to make sure that my sides that are congruent are always opposite the angles that are the same. All right, let's do a couple more and we're going to end this one. Here we have a side, an angle, and a side. The reason why I didn't use hypotenuse leg is, notice I didn't talk about the hypotenuses at all. So this would be a SAS congruence problem, and we get triangle CDE is congruent to triangle FGH. That should be very familiar to yesterday. Okay, we already did number 8 before, but we're going to do a couple more together in a little bit.